Hello students, I am Jayanta Chakraborty, faculty of Sri Ramakrishna Institute of Science and Technology of Mechanical Engineering Department. Today I will discuss the limit, fit and tolerance for mechanical engineering drawing for third sem second year mechanical students. Come to the topic, what is interchangeability? The term interchangeability is a principle normally employed for the mass production of identical parts within the prescribed limit of size. This facilitates an at random selection of required components for an assembly. The parts so selected can be safely be used in making an assembly and they will give the satisfactory service. It is more advantageous than the other principle. The advantages of this applying this principle in this mass production system, those are: number 1, less skill is required. Number 2, measurement and checking is very easy. So the rate of production is also high and the dimension of mating parts are accurate for the required fitting. Now come to the classification of the interchangeability. There are three types of interchangeability: universal interchangeability or the full interchangeability, number 2, selective assembly, and number 3, match fits. Let us discuss about the full or universal changeability. In this type of interchangeability, in an assembly, any components can be replaced by a similar component without any further processing. As example, we need not to change whole assembled parts if it becomes disassembled. We can save it by replacing any screw or rivet made with proper dimensions. The second type is selective assembly. In this type of interchangeability, the parts of any one type are classified into the same number of groups according to the size. Any one part from this particular group can be assembled with a part from the corresponding mating groups, and the resulting assembly is expected to facilitate the desired function. In this, it is essential that in the corresponding categories of the mating parts, the number of parts produced is same as each category, otherwise the number of parts may be left without any mating parts in the corresponding category. The last type is matched fits. This type of the interchangeability suit only for the small assemblies. In this exact size of the finished part is accurately measured and then mating parts is made to match with it. As example, a hole can be made and its exact size measured, then a shaft can be machined to match this hole. Next, the limit system. It is a system which comprises the standard allowance and tolerance associated with the definite ranges of the basic size by which the limits of size can be selected to obtain a desired type of fit in the assembly. Before we proceed further, it is essential to note the definition of the some important terms used in the limit system. The terms are nominal size. Nominal size, it is a size of a part by which it is designed as a matter of convenience, particularly in commercial use. As example, by a 12.7 mm spanner, we do not mean a spanner having an opening of 12.7 mm with it at the end. It actually indicates the inside dia of the nut of which the spanner will shoot. Obviously, the said opening will be equal to the distance across the flats of the nut. Then come to the actual size. It is a measure of the actual dimension of a part has attained after it has been finished. Next, basic size. It is a theoretical size which is common to both the parts of the meeting part, usually a hole and a shaft. Limits of size of each of these parts are derived from the size by the associating the predetermined allowance and tolerance to it for the obtaining the desired fit or a particular application. Sometimes basic size and the nominal size may be same. Now come, what is limit, fit and tolerance? From the slide, you can see to extreme permissible size of a part between the which the actual size is contained are called limits. The relationship existing between two parts which are to be assembled with respect to the difference on their size before assembly is called the fit, and the tolerance is defined as the total permissible variation of size. As already explained, in the extremes of the very finished size of a component can be expressed as the either is design size associated with the two limits of tolerance or directly as the two permissible extremes of the finished size. For example, a hole is having 25 mm dia design size and carrying a tolerance of plus 0.025 mm. For unilateral hole basis, unilateral means the tolerance is get in one end, can be represented as high limit 25 plus 0.0025 is equal to 25.025 mm and the low limit is 25 mm only. Since this is unilateral, so tolerance is at the upper end only. For bilateral, where the tolerances occur in both ends. In case of bilateral hole basis, it will 25.025 mm high limit and the lower limit is 24.975 mm. It becomes that 25 minus 0.025 is equal to 24.975 mm. The difference between high limit and low limit is called the tolerance. Now come the hole basis and the shaft basis system. Hole basis system, where in this system the design size of the hole is the same as its basic size and the different grades of fits are obtained by varying the tolerance and the allowance of the shaft. Here the hole size is constant and shaft size is adjusted by the machining of the shaft. In case of shaft basis system, in this system the design size of the shaft is the same or constant as the basic size and the different grades of fits are obtained by varying the tolerance and allowance on the hole. It means the shaft is not machined and the size of the hole is adjusted by machining internal diameter. Hole basis system has the achieved preference over the shaft basis system in modern industry because it is easier to machining a shaft than the hole. Thank you.